Well, thank you so much for joining. I know it's Friday, and I know it was a long night. All of you guys had fun last night? Awesome. So I'm going to talk about infrastructure as code and how you can use certain multi-cloud tools like Ansible and Terraform on Azure. So just to get started, a quick refresher of things that you guys are probably already aware of. So traditional infrastructure, you guys, different walks of your organization, you probably are already buying hardware and putting them in your data centers, or we do that as a part of cloud. In Azure, we also buy physical hardware, right? And so this is the truth, this is the reality of any cloud or on-prem system. So the way it works is that someone needs more capacity, he thinks about it, he calls, he makes a phone call, gets the hardware delivered, and that's how you get more capacity. Then, when the virtualized time frame kicked in, we started getting virtual machines. And so you could manage some part of your demand life cycle within your organization and get your customers virtual machines. So that allows you to scale in and out a little bit, and that allows, in case of public cloud, it allows us to scale in and out a little bit because we get virtual machines, and that's your core compute. So you guys are already doing some degree of infrastructure as code if you're using virtual machines in any shape or form in your on-prem setup. If you're using System Center or VMware Sphere or any other tool, you are already, in some sense, doing some degree of infrastructure as code. So it's not something you're not aware of. I'm just trying to draw some attention to that these are things that you're kind of already doing, but it becomes more structured as you go into cloud. So what is really infrastructure as code? Well, it's not Matrix, but it gets close to it, right? So the first thing that we have to understand on infrastructure as code is that cloud is everything is software defined, and to have anything software defined, you have to write code for it, right? And so when you go to cloud, any cloud, be it your on-prem now with a hybrid setup, or you're using any public cloud, you're going to have to define the infrastructure that you need in some form of code. Now it could be that you can go, you want to try something out, you go to portal and you click a few links and deploy a VM, or you may use the standard tools to go and deploy virtual machines or containers or network, etc. But as you can soon notice, all of these things are actually defined in some shape or form by calling an API or calling some command line tools. So the concept of infrastructure as code is kind of making it symmetrical to a code-defined infrastructure that allows you to structure what infrastructure you need, when you need it, and you can create and destroy infrastructure just the way you can create and destroy code. So that's the core concept of infrastructure as code. Now, once the infrastructure code as code notion comes in, you will use various different tools to achieve your goals. If you're just purely using Azure, you'd want to use the Azure ARM templates to go and deploy your resources. You could use the Azure CLI to go and deploy your resources. You could even use PowerShell to go and deploy your resources. Either which way, you're going to have some degree of code that describes your infrastructure. But the world is moving towards a multi-cloud hybrid solution. And in that case, you need tools that can go across cloud, and you're not training your DevOps engineers to be tied to a particular cloud tools if you are planning to have any multi-cloud strategy. So with that said, I want to talk about what are the common deployment patterns that exist in cloud today. So there is either a mutable infrastructure or immutable infrastructure. I'm going to give you some details on what these are. So mutable infrastructure is something that you probably are already using or are aware of. This has been the concept forever. There's a new name to it that has been attached. It's capable of change. So think about you setting up a file server or you're setting up an AD on-prem. you know that it is going to be capable of change because you need to go and do the updates. You need to go and add more disk or resources to that infrastructure. So it's a pattern that you're already aware of. You basically install the infrastructure and do all the updates in place. It's something that you and I are kind of used to, and that's what we do regularly, right? Even if we don't do it for our production environment, this is exactly what we do for our dev or even our regular machines that we use. Like, think about all the laptops that you're using right now. It's all immutable infrastructure, right? For an organization standpoint, it's immutable infrastructure because it's changing everything in place. And finally, most of your legacy software is going to be managed by this pattern, right? I mean, it's, I'll talk about immutable right now and kind of draw an analogy, and that will make more sense. So immutable infrastructure is generally not capable or susceptible to change. You're trying to make a decision that whenever you're going to deploy the infrastructure, you're making a conscious choice that most pieces of the compute infrastructure does not change in place. Now, that doesn't mean that you're not going to update your systems at all. You're simply going to make sure that you're not going to change things in place. This allows you to be more methodical, make sure that you have tested the pattern before in your dev test environment before you roll anything out in production. All deployments are per specification, right? So you exactly know what you're deploying every single time. So if you want to go back or forward, you can easily do that. It's a newer pattern overall. It's cloud native. Most people are using this pattern now because most cloud native applications are built with this paradigm in mind. If you're going to go as far right as using containers, this is kind of built into the entire ecosystem of containers. But even if you're not using containers, just using infrastructure as service, most newer applications will work, and you can structure them to work in an immutable fashion. And finally, it works best with newer applications, right? You would not have, it's going to be difficult to make legacy applications work with this pattern. I'll give you an example for this. You're going to set up an AD on-prem, and you want to move that to cloud. If you just want to move that as a lift and shift and you move that to cloud, there's no way you can come with a pattern that's going to say, oh, this is going to be immutable in nature. It's going to be extremely hard for you to do that. And it's going to be a nightmare to always migrate the state from one AD to another. So either you take a leap and go say, I don't want to manage this at all anymore, and I'm going to go and let AAD manage all my identities. But if you're going to have a traditional application like that or a database, it's going to be extremely hard for you to go and follow this pattern. So it's not one way or the other. I mean, some people think that we can go just immutable or just mutable. It's just not the thing. It's the reality is that you're going to have both patterns in your in any large scale deployment. So with that said, I'm going to dive deep and give you a demo on a pattern on infrastructure where I've deployed both mutable and immutable, so that you can get a good sense of what I'm talking about. All right. Everybody knows my password now? All right, cool. So let me start with what topology I have deployed so that it makes sense and you guys can relate to it. What I've done is I've taken this sample. This is available to you guys in Azure Quick Start template. It's a 201 traffic manager sample. All it does is it goes and creates a traffic manager profile, sets up a bunch of Ubuntu VMs underneath, and deploys Apache underneath for this Ubuntu VM. So if you're doing any front-end workloads, this is what this application is going to do. So this template is going to do. So it goes and creates the traffic manager, all your NICs, all your public IP associated with the VMs, and goes and configures those VMs to have Apache running. And so by default, this template is going to go and deploy Ubuntu 14.04. I've deployed this in my setup. Obviously, it takes time, so I'm not going to have you watch a deployment, but I've already done that ahead of time. And so what you can see in Portal right now, and just want to make sure that everybody can see this. Is it visible? All right. So this is an entire resource group where 3 VMs are deployed, and right now you will actually see the 4th VM, so kindly ignore that. But 3 VMs are deployed, there are public IP associated with each one of them, and I have a traffic manager profile that will route traffic into these VMs. So as you can see, I have 4 traffic manager endpoint rules that would actually direct traffic to the VMs that I've created. I have endpoint 0, endpoint 1, endpoint 2. These were the 3 VMs that gets deployed when you deploy this template. The 4th endpoint is something that I'll talk about shortly. So the first 3 endpoints, all of them are running, if you deploy the template right off the bat, all of them are going to be running Ubuntu 14.04, right? So one of the things that you want to do as a system administrator is you want to be able to update your application, the OS or the application that is running in the system. So as a part of a mutable infrastructure, what I'm going to do is I'm going to go into one of the systems and actually go and update the kernel from the Ubuntu release from 14.04 to 16.04, which is kind of sort of late. It's not the 17, which is the latest. I just want to be a little pragmatic and be one release lower than that. So I'm going to SSH into the box that I want to go and update. Now, of course, all of you guys are excited to see a Linux kernel update, which is going to take an hour. So I'm going to spend the rest of the demo showing you that. I'm just kidding. I've already done one of the machines, which is updated, right? And I'm going to show you that it is actually updated. And I'm also going to prove that it was actually not installed as 16.04. So this is a system that I've already updated. As you can see, it's actually running 16.04 version of Ubuntu, right? But you guys can ask me, hey, you could have just deployed 16.04, right? And I'm going to prove you otherwise. So one of the things that we also announced a while back is the ability to get metadata about a running VM on Azure. So you can hit a local endpoint, a well-known IP address, 169.254, 169.254. This is going to give you information about the VM as it was deployed. So when I do this, what I notice is that it identifies the system that was deployed as 14.04 Ubuntu, right? Because that's what I did as a part of the template deployment. But what I have done is, following the mutable infrastructure, I could have used, update by hand, or I could have used an Ansible playbook to go and update my script. If it's a Windows system and you're used to System Center, you could have used System Center to go and update it. You could have done remote PowerShell execution. You could have used any tool to go and update the system in place. Now, my availability for my users were not stuck because because I have a traffic manager profile on top of this. So I still have a high availability system running. I still have 2 endpoints, so I can go 1 VM at a time and go and update this to the latest kernel. And that way, my users are not impacted, and yet I have updated the system in place. So this is a pattern that I can do, and I think most people are familiar with this pattern already. So what do I have to do for immutable infrastructure associated with this? So remember the 4th VM that I was talking about? What I went ahead and did was, in this resource group, I created a new VM. This new VM was created using 16.04. You could have your own custom image. I had just 16.04 that I used by default, and created a new VM. Now, what I've done with an immutable infrastructure pattern is, to give you an example, I created this 4th VM, created a new endpoint in my load balancer, the traffic manager. And all I can do is I can create 3 new VMs like this and just shape my traffic to get to those new endpoints, and then delete my old VMs that were of 14.04. So if I have to use an immutable infrastructure pattern, all I will do is create an infrastructure fresh, which is create my new compute instances fresh, and simply shape my traffic out to the new instances and remove the older one. So that's a simple example that you can relate to in terms of how you can leverage the immutable pattern and mutable pattern, in a similar example. So all I did was went and created this VM, created a new endpoint within my traffic manager profile. Now that I'm already done with that, and I don't care as much for this demo about higher availability, I'm just going to go and disable the previous endpoints, which are running 14.04 version of the Ubuntu kernel. And once I'm done with that, my traffic manager is still up. I can click on this, and my application is still up using the 16.04 version. So I have achieved both mutable and immutable in the same deployment. To just give you an example, but typically you don't have such tight to the hip pattern for mutable and immutable. You'd have one deployment which is mutable and one deployment which is immutable. But I just wanted to give you an example to relate to it. So with that said, I'm going to switch back. I gave you a quick example of mutable and immutable infrastructure, right? I'm just going to quickly touch base here and talk about some industry trends and get deeper into Terraform and Ansible. So the first thing upfront from a data point of view is hybrid is real, right? I know there have been talks one way or the other about it, but hybrid is real. There's research done associated with this, and a lot of enterprises believe that hybrid is going to be the real pattern going forward. Now, there would be some enterprises who will move everything to cloud. That's also true, but there is still majority who would have an hybrid setup. So any tools that you'd use would have to keep hybrid in mind. I mean, that's the whole trend that I'm talking about here. The second thing that you'll have to plan for is a couple of data points based on two different research that was done. So there was a dimensional research study that said that 77% of the respondent of that survey were going to deploy to multiple clouds, right? And so that's also going to become a reality, right? And diagonally opposite to that is what Gartner did. A Gartner study came about that 70% of enterprises will have a multi-cloud strategy by 2019. So multi-cloud is going to become a reality, right? Every major enterprise will shape towards multi-cloud. In fact, even medium businesses will shape towards multi-cloud. So we have to start thinking about multi-cloud today. We may just be entering into one cloud, but multi-cloud is going to become a reality. So that's the two data points I want to talk about. The other two aspects of this is there's an explosion of multi-cloud tools out there, right? I mean, you see Terraform, you see Ansible, you see SaltStack, you have Chef, Puppet, you'll have OneOps. There's a whole plethora of tools that have been generated, and based on where you are at and what your organizational needs are, these tools are going to be something that you're going to be leveraging going forward. So with that set as basis, I'm going to jump into the two tools that I'm going to talk about today, Terraform and Ansible. So let's start with why Terraform, right? How many of you guys are aware of Terraform? Just a hand. Very cool, very cool. So Terraform, I'm going to skip. You guys already know. Most of you guys already know. But for those who didn't, it's a product to provision infrastructure and applications over multiple clouds. So it could be private. You could have a VMware installation on-prem or Hyper-V, or you could have a public cloud offering, or you could have Azure Stack, right? And that's the philosophy of the tool is to go and meet you where you are at and give you support for wherever you want to deploy infrastructure. It's multi-cloud. It has an easy language, JSON-like language called HCF. It's hashy configuration format to go and describe your infrastructure code. And as I said, supports both on-prem and cloud. So and their motto is provision any infrastructure for any application, right? I mean that's how they roll. So with that said, I'm going to give you a quick demo and walk through on Terraform and Azure, the things that you can do and what basic steps on Terraform and Azure, and then come back and talk about what all different areas that Terraform supports on Azure. All right, I'm going to go fast now because I'm. How many of you guys have used Cloud Shell? Of those who have not, Cloud Shell is a simple bash prompt that you get, or bash or PowerShell prompt based on where you are at, directly from the portal. So I'm right now logged on in the portal. You go to the top prompt here, click, and it actually goes and creates and provision a container for you with all of your credentials baked in with Azure CLI. So it's just available for you. Everybody can see the text in Cloud Shell? OK. So first thing I want to show you with Terraform and Azure is Terraform is built right in the Cloud Shell experience. So we have actually baked Terraform binary in Cloud Shell itself. So when you come to your Cloud Shell and you do Terraform, it's just present. It's just integrated in the experience. You don't have to go find a release, download something, and do this. This is going to be available for you and goes with you wherever you are at. So that's the first thing that I want to talk about. For those who have used Terraform, Terraform needs to talk to Azure, right? It needs some credentials to talk to Azure. How many of you have actually tried Terraform on Azure? OK, that's a number. So the first thing that you need to configure Terraform is you need a service principal. You need to go and create a service principal in your Active Directory account. That'll give you a automated way of talking into Azure. So there is documentation. There's simple steps to go and create an identity in your Azure Active Directory to go and create a service principal, right? While I understand that this is something that you would have to and would need to do for any automated deployment. You might have a Jenkins pipeline that you want to go and deploy using Terraform. But we're taking one step forward and actually giving you an example, giving you an ability to use the auth that you already have in Azure CLI. So no need for service principal anymore with Terraform. You can simply come, go to a directory where Terraform files are. So I have a simple Terraform script here, which goes and creates a resource group in West US, right? It'll simply go and create a resource group. So as I said, it's a simple JSON-like language that goes and describes resources in Azure. So I can simply come here, do Terraform init. What this does is it goes and downloads the Azure provider for Terraform and gets it down onto your Cloud Shell environment. Keep in mind, all of this is storage back, so everything that you're doing will always move with you. And then I do Terraform apply, or I can do Terraform plan. So one of the advantages of Terraform is it actually gives you plan ability. So it'll actually tell you what exactly it is going to do. So as you can see, it says, my plan is to go and add one new resource, and that is of this kind. So if you have a larger complex template, it is also going to be able to do that. And then I simply do Terraform apply, and it goes and provisions a resource group on Azure, right? So it's as simple. You can have more complex examples for the same, and I'll give you places where you can get quickly started. So one place that you can go, and this is a GitHub repo that we have for Terraform provider. There's a whole bunch of examples here, ranging from creating 2 VMs with a load balancer, or user VM with a user image, scale set, or SQL database, etc. So there's a rich set of tools available and examples available for you to go get started, right? So in interest of time, I'm going to show you what all do we support today, and then come back and answer any questions specific to Terraform. So first thing I want to talk about resource support, right? One of the things that you have to be aware of what all resources we support. We support storage, VM, scale sets, network. There's a whole set of resources that we support today on Terraform, right? And then we add new resources really, really fast. So how many of you are aware of Azure Container Instance? It was something that we announced 4 weeks ago. There's support for that in Terraform now, right? How many of you are aware of Azure Event Grid, right? There's support for that in Terraform now. So we are working very closely with the open source community and adding support for Terraform for various different Azure resources. And with that said, I want to give you a quick example of a customer success. So folks who have ever heard of OpenAI? OpenAI, anyone? So OpenAI, backed by Elon Musk, they did a deployment on Azure. All of the deployment that they did on Azure and all the tests that they did on Azure were completely deployed via Terraform, right? They used the entire deployment was 100% Terraform, right? So this is a customer example, right? I mean, they want to be flexible, they want to be able to deploy on one cloud versus the other. They want to go from Google or Azure or Amazon, right? They chose Terraform as their common tool to go and deploy and be successful. So with that said, just what is coming next, we're going to have, additional resource support, Azure Stack support, and we'll do a bunch of enterprise integrations. I'm going to change gear, talk about Ansible. Folks who are aware of Ansible? Awesome. So Ansible is another awesome tool that lets you do a lot of these things. Most of you are aware of Ansible because you have used it for configuration management for kind of a mutable infrastructure. How many of you are aware that Ansible also is used to deploy infrastructure? Fewer, right? And so we have Ansible is a simple, powerful tool, no agents, just SSH-based to go and deploy. It's really powerful. I think from an open source point of view, has the most community contributing to Ansible, right? It's agentless in nature. You simply have module support, define your playbooks, and go and deploy or configure systems using Ansible. So Azure and why Ansible, right? We want to meet you where you are at. If you're already used to using Ansible, describing playbooks in YAML, we want to be able to support you where you are at. So Ansible today supports more than 16 or 18 different Azure resources that you can go and deploy via Ansible. It's very simple to use. Again, you can have both mutable and immutable patterns with Ansible. So that's something that's coming in shortly. There are some Python dependencies. I'm going to skip the slide. You can take a look at this when you want to go ahead and try this on. To talk more about Ansible, I have a guest speaker today, right? I want you to have the experience from the horse's mouth. So I'm going to call in Matt Davis. He's a serial principal engineer from Red Hat itself. He's going to give you a quick overview of Ansible on Azure and associated functionality. Please welcome Matt.
Thanks, Hari.
I'm going to switch.
Morning, everyone.
Oh, sorry, you're 6.
Yeah. There we go.
There you go.
Hi. So I'm going to give you, I'm going to kick off a couple of demos here. Unlike Hari, I didn't run my demos ahead of time. We're actually going to do it live, so we'll see how that goes. But I'm going to kick off a couple of demos here just to kind of put the rubber to the road with the stuff that Hari was talking about. And then while those demos are running, we'll kind of take them apart and show you what's really happening under the covers there. So the first one I'm going to run here is we're going to provision. Both of these demos are basically doing the same thing, but they're doing it in 2 different ways. So the first one that I'm going to run here is provisioning a couple of VMs and all the bits underneath in Azure, and then deploying they're going to be running RHEL 7.3, and then we're going to deploy .NET Core and a .NET Core application on top of that using Ansible in Azure. So we'll kick that one off. And in this other window over here, I'm going to do the same thing, except instead of using Ansible to directly provision all those resources in Azure, we're going to use Terraform to do the same thing, but we're going to use it from inside of Ansible using a preview Terraform module that someone on our team built. So we'll kick that one off here as well. Okay. So let's just look and make sure those look like they're going. Okay. So while those are running, let's just kind of talk about the basics of what's going on here. So let's see, the first one we'll look at is that Terraform one. Yeah. So this is a very simple Ansible playbook that's going to install, that's going to kick off that Terraform infrastructure provisioning, and then it's going to deploy this the eShop on web .NET Core sampled application. So what's going on here? I guess let's talk a little bit about kind of some basic Ansible building blocks here. The first one that I'm going to talk about is inventory. So inventory is core to everything that we do in Ansible. It's basically, at its simplest, inventory is like a list of hosts and groups and grouped up hosts and some variables like connection variables. How do I connect to these things and other things like that. At its simplest, that's often just like when people get started with Ansible, they usually use a static inventory to talk to things that already exist. So that's just going to basically be like, what's the IP address of this thing and how do I get into it? Because remember, Ansible works everything over SSH or WinRM if you're doing Windows. So it's just basically the inventory is like, how do I talk to this thing and what is it? And then you can group those things up inside your inventory by like functional groups, like these are my web servers, these are my DB servers, or by location or any other kind of way that you want to slice and dice the inventory. Now, when you're talking about working with things in cloud and especially provisioning things in cloud, a static inventory is not going to work for you, right? Because you're creating new hosts as part of your automation. So Ansible also has a concept called dynamic inventory where we can go out and query arbitrary, you can get it from anywhere. So a dynamic inventory could be based off of a spreadsheet. It could be based off of a CSV file. It could be based off a cloud API, which in this case, for Azure, that's what the Azure dynamic inventory script does. Goes out and queries an Azure subscription and says, give me all the machines in there. And then groups them up. It automatically creates Ansible groups off of those things based on the way those things are tagged and like what resource groups they live in and things like that. So like in this case, if we look in my inventory directory here, I have the Azure RM inventory script and some configuration that goes along with it to tell it how do I want these things sliced and diced. I'm not going to show you the script itself because that's just something that we ship with Ansible. When you want to use one of those, you just drop it in with your content and use it. So the next thing to talk about is this playbook that we've got here. So the playbook is kind of the biggest unit of work in Ansible. So a playbook consists of a list of plays, and a play targets a host or group or multiple of those things as you've defined them in your inventory. So in this case, my first play here, it says it targets the local host. So every inventory in Ansible contains localhost, which is the machine that's running Ansible. Ansible is just a command line tool that sits on a machine. So this play targets localhost, and I've told it that I'm not interested in facts for this thing because I'm going to be out doing Azure stuff, so I don't care about my localhost and what OS it's running or anything like that. So I just told it don't gather facts. And then I only told it one thing to do in this play, and I said I want to apply the role infra Terraform, and I want to do that from my local host. So infra Terraform is a role in Ansible is kind of it's like kind of a repackageable list of tasks, a way that we can get stuff done. So it's kind of a role is kind of a container for a bunch of tasks and like the files and templates and the other things that you might need to include for, it's like everything that I would need to, deploy a set of infrastructure or deploy a particular application. It's just kind of wrapped up and repackageable so you can distribute them and reuse them and things like that. So I've got this infra Terraform role, and we'll show you what that looks like. Okay, so these are the two tasks that make up the infra Terraform role. We're using this preview Terraform module that I mentioned. If you can't get this from Ansible today, but we'll probably be shipping this in Ansible 2.5, so it'll start showing up really soon in there. So I just give it the project path. I tell it where is my Terraform content, and then I register the output from that. And then the last thing that I have to do this is one of the another kind of core tenet of Ansible is like our tasks are kind of they're expected to be idempotent, which means we can run it over and over again, and it will only make changes when it's necessary to make changes. So the Terraform module uses that Terraform plan, if you're familiar with that. It uses a Terraform plan to go out and say, like, is there anything that I actually need to do here? And if there is, then we go ahead and apply that. If there aren't things that need to do, then we just have the module return. There's no changes, nothing to do, so it comes back really fast. We want to use that because remember I said Ansible's got, we're using a dynamic inventory in this setup, right? So when I first run this, the only thing that's going to be in my inventory is localhost. I haven't created any cloud resources yet. None of them exist. So, but in order to do something with those cloud resources after I've created them, I have to get them into my inventory somehow. So after I run Terraform, if Terraform goes out and makes changes, which if it registers any changes, that means that like I made new hosts, and I want those hosts in my inventory so I can do something with them. So I'm making this refresh inventory call here at the end. So I say, if the Terraform stuff registered a change, let's go and refresh the inventory from Azure so that those hosts show up and I can do something with them. So let's see. I will show you what the actual Terraform that we're running here looks like. So this is a little more in depth than Hari's demo for the Terraform stuff. So we're creating a resource group, a virtual network, and a subnet, and a public IP, a network interface, and finally a virtual machine that has various properties that we want to use. And then the very last thing here, if you'll notice, I tag the virtual machine with this web server. It's a VM type of web server TF, and so that'll come back. We'll see that again in a minute. So if we go back to our original provision Terraform here. So the first thing we're going to do, we're going to apply that infra Terraform role. So that's the thing that's going to go out, stand up all the cloud infrastructure. We haven't deployed anything to that yet, though. That just says, like, make sure there's some hosts out there for us to do that stuff with. And then remember I said that those things are automatically assigned to Ansible groups based on the way that they're tagged. So what I did here is that it's going to automatically create a group for us in the Ansible inventory called VM type web server TF. Remember that web server TF tag that I just applied? So that says every host that's tagged this way, I want to deploy the eShop on web role to it. And we'll dig into that eShop on web, the actual like deployment role in a second. But what I want to show you now is the the Ansible native equivalent of what's going on there. So if we go down here, the other demo that I kicked off was the provision Azure role. You'll notice it looks very much the same, except it's infra Azure instead of infra Terraform. The actual eShop on web, the post-provisioning stuff that we're applying is exactly the same. Ansible doesn't care how the infrastructure got created. Just know that once it's there, we can apply the same stuff to it no matter what. And again, that works the same way, whether it's like Linux, Windows, networking infrastructure. Like we work with all of those things. So let's take a look at that. Let's dig into that infra Azure one here. So again, you're going to see a lot of the same kinds of things here. There is an Ansible module that corresponds to each one of those Azure resource types. So we've got a module that creates resource groups. We've got modules for creating virtual networks, subnets, virtual machines, all those things. And you'll notice, like, if you look at that Terraform stuff and the Ansible stuff, we're kind of passing the same things. These things all kind of work the same way from a user perspective. Now, what's happening under the covers is very different because Terraform uses kind of a graph model and like tracks dependencies internally between all of these different resources. Ansible doesn't do that. Ansible is very much like linear task-oriented stuff. So if there are some cases where Terraform might make more sense. If you want kind of mutable cloud infrastructure where you're going to go and put something out there and then you're going to have Terraform, you're going to over time like add new things to it and make changes to it, and you want to have kind of like automatic tracking and have Terraform or tear down things in the middle there, Terraform might be a better choice for that. If you want just kind of more the immutable, like on the infrastructure side, Ansible is fine for that. You'll see a few other things in here, like this is how we do like variable substitution in here. So these things that between the handlebars, if you're familiar with the Jinja in Python, that's how Ansible does this. I don't want to go too much in here, but anyway, so you can see we're creating all these same kinds of things, and at the end of it here, we're tagging things the same way. So I'm just passing. I'm passing some tags here that says, like, yes, this is a web server, and I'm using that same VM type tag, but I just gave it a little bit different key so that we can find those in the inventory. And again, if we go back to that top level, we say for everything that's in our VM type web server dynamic group there, we want to deploy that eShop on web role. So let's see what that looks like. eShop on web. Actually, before we look at that, eShop on web depends on .NET Core, so we made a role for .NET Core as well that deploys that. So it's very simple. We just go and make sure that and again, these things are all kind of idempotent tasks. If we were to apply this role multiple times, after the first time when all of the stuff, once the RPM key's been trusted, once the stuff is installed, this thing is just going to run back. Like it'll take just a few seconds to come back and say, like, hey, there's nothing to do. It's already in the state that you asked it to be in. So we're just gonna, we go and use Yum repository to add the Microsoft repository where the bits live, and then we install the prereqs and then make sure that the .NET SDK is present just using the Yum module. And then the actual eShop on web application deployment, we deploy it straight out of GitHub. So we say, make sure that Git is there first, because we need to be able to do a clone from GitHub. And then we say, oops, ensure that the service user that we want to run it, because we're not going to run this as root, right? We create a user based on some parameters that we've passed in. We just make sure that the application path exists, and then we go ahead and clone the GitHub repo and make sure that it's current, and then set some ownership stuff up using our file modules, and then we just go through and we restore the packages and kick off the rest of the app deployment stuff. We make sure that there's a firewall port open. And then the very last things that we do, we don't want to return, we don't want to move on with our playbook deployment until we're sure that that service is actually answering and behaving itself. So the last thing we do here is basically bang on the service endpoint until it comes back with a response that says, yeah, it looks like this thing is actually running. And then the last thing I do here is just debug, print out the endpoint of the host, because it's a dynamic IP, and I didn't assign DNS names or anything in this demo. I didn't want to get too in-depth with that. So let's go if we can check in on our demos here and see if they worked. Okay, that looks promising. So we got our output here that says what the host endpoint is. This is the single one that we did with Terraform. So, and Ansible shouldn't have come back until that thing was up and answering. So if I go open this link in a browser, it should, yep. So we have our little store app, and it's running. So let's look in on the Ansible version of that as well. Oh, looks like one of them broke. But it's okay, we deployed to 2 hosts, so it's all good. I'm actually curious what broke here. Looks like the SSH service didn't come up on the other one, but okay. Well, anyway, we got one of them working, so let's see. It should be the same thing when we go to that one. Yep, and we got it. So that's cool. Our deployment kind of worked. And so the cool thing about this, like with Ansible now, like if I wanted to, I could go and rerun this, and it would go through and come back and say, and who knows why that one failed? Like it could be a flaky network connection or something. But this is all idempotent. So who cares? Like if I run this thing again, notice most of these things are all coming back as green. They're just saying like it's already in the right state, so there's nothing to do here. And it looks like let's see, if that other one comes back. But while that's, I'll let that run again for a second, and we'll see if we can get the other one to come up. But ultimately, though, we talked about that Terraform and Ansible kind of we have a little bit different ways of looking at things, but they ultimately you can get the stuff done in whatever tool you like, and Ansible is kind of a big tent, so we like to again, we like to let you use the tools that you want to use. We like to use the technologies that you want to use. So it's just when you're evaluating tools, just kind of figure out what your requirements are, and then play around with that a little bit and see, like, does Terraform make more sense for this? Or does Ansible make more sense for this? And use whatever works for you. It's all good stuff. And the big point is, like, you should be automating this stuff one way or another. Like, there's a lot of great tools out there, and just that's I think that's about it.
Awesome. Thank you, Matt.
Yeah.
Really appreciate it. So as you can see, regardless of which tool that you need or you want or you choose to use in your infrastructure, you have to write it in code so that you can know what change has happened from one version to another. So finally, just want to talk about a quick module support. Ansible, just like Terraform, there's a whole bunch of modules that we support today. So you can go and deploy pretty much the base infrastructure as a service, any VMs or VMSS that you would want to need. What we're going to do forward is we're going to allow for device login, just like Terraform. Ansible will also have device login, so you can do dev tests easily. You don't have to use Service Principal. Today for Ansible, you need Service Principal. And we're going to expand support with Azure Stack going forward. Quick summary of where we are at. Infrastructure as code is the future. We have to get on it right now. Multi-cloud tools like Ansible or Terraform will make it easier for you guys. And there will be a mix of mutable and immutable deployments in future, so be aware of that. With that said, thank you guys.